Yes, it is my guess.
All right. So let's take a look quickly at a series example PMI. You may have done this in Form 5, but we do that. I mean, unit 1, unit 1. Let's get one from here. We don't really have much of these in the past papers. Right, let's look, just do like 2 analysis, right? Right, so we're taking a look at PMI for a series, right? So let me do a medium and then I'll give you one of that. What do you call it? Remember R cube, right? How do I? I usually would remember that. Sorry about that. Yeah, I don't know. I usually would remember by mistake. I was about to change up that. All right. So we want to prove this by PMR. These are R's, these are N. Right here, you may have done this in Form 5, Form 6, you just go on, I mean. All right. All right. So I'll do one as a quick example. This is a little bit different to what we were doing last week, right? Remember last week we had to do the sequences, right? These are like the normal ones that did in unit 1, right? So you start with for n is equal to 1, right? Left hand side, plug in 1 here, you'll get 1 by 1 plus 1, right? Which is 2. Right hand side, plug in your 1 here, you'll get 1/3 by 1. 1 plus 1 is 2. 1 plus 2 is 3. 1/3 of 6, that's 2. Both of them equal, therefore it holds at n equal to 1. That's okay? What's the next step? Next step, we have to assume true for n equal to k. So all I'm going to do is just change all the n's to k's. So that'll be the summation of r going from 1 to k of r by r plus 1 is equal to 1/3 k by k plus 1 by k plus 2. Okay, that's the statement that we have to assume is true, and then we have to now show it holds for n equal to k plus 1. Right? What are you gonna do now? Just plug in k plus 1, k plus 1, k plus 1, k plus 1. Okay with that? Remember the steps? Right? So the summation of one line you'll see down here, right? R going from 1 to k plus 1 of k plus 1 by, sorry, that's R, that's N, right? R by R plus 1. I'm putting k plus 1 here, here, and here. So I'll get 1/3 k plus 1, k plus 2. So again, we're trying to prove this, right? This is the statement that we're trying to prove. All right? Now, where do we start? In the sequences, we start with what they gave us. But in the series, where do we start? Remember? Huh? We start with, now before that, before we put our team. So the first thing is since the summation of r going from 1 to k plus 1 of r by r plus 1 is equal to something. What is always equal to? Right, sum to the k plus the k plus 1 term. This here, remember, it's a summation, right? For those who forgot what a summation is. Summation of r going from 1 to k plus 1, right? This is telling us that we adding up all the terms, the first term, the second term, third term. Actually, let me be more specific, right? Of r by r plus 1. What it's saying is that we adding up the first term, 1 by 2, which is 2. Second term, 2 by 3, which is 6. Third term, 3 by 4, which is 12. All the way until the last term, right? So the last term is what? Put k plus 1 here. And put k plus 1 by k plus 2. So this is saying that we summing up all the terms when r is 1, r is 2, r is 3, r is k plus 1. Is okay with that? That's it? Right? This here is the symbol. This is what this symbol represents. That's okay? Yeah. So just one quick question. What's the term just before this? What's the term just before this? K, right? So if I plug in k here, I'll get k by k plus 1. That's okay? That's the term just before this. So first term, second term, third term, second to last term, last term. All right? If I were to group up this now, what is equal to? The sum of the first term to the kth term. That's okay? So this is equal to the sum of the first term to the kth term plus the k plus 1 term. Correct? This is the k plus 1 term. So I just kind of went over that to remind you this general statement. Every time you're doing a PMI and you have to start to prove, you prove this left-hand side here. You want to prove that this is equal to this, right? To this here. So you have to remember this general rule. This is always equal to the sum r going from 1 to k plus the k plus 1 term. All right? Okay with that? Right? And as we were saying, this is what? We already know this. This is this here. 1/3 by k plus 1 by k plus 2. Right? What's the k plus 1 term? The k plus 1 term is just put in k plus 1 here. And there. That's k plus 1 by k plus 2. So here's where you should reach without even much thinking. Right? The substitute n is 1, substitute n is k, substitute n is k plus 1. Then you write the general statement that would always hold. Right? This is what we have here. And this k plus 1 term is always put in k plus 1 in here. And we get this. Now we have to take this and make it look like this. Anybody remember what to do? What's the first step? What's the first step? How to make this look like that? You can factor out, right? You can factor out whatever come on. But before I do that, remember, this is our 1 here, right? Which is the same as 3 over 3. So we can factor out 1/3. We can factor out k plus 1 from here and here. And we can factor out k plus 2. Right? We'll be left with k here. We'll be left with 3 here. That's it. 1/3 k plus 1, k plus 2, k plus 3. That's it. And then you write your usual statement. Okay? Online, any questions? Any questions there online? Let's do one easy, one hard, and then we move it on from this, right? Harris, are you okay with this? Harmony? With harmony, you in this cluster? Harmony. Harmony in your cluster. Right, Shivani, you remember these things? William, you following? Ready? Let's try one, right? And I'll give you one easy one, right? Try that, please. Try this here, please. Bill, try this, please. Bill, try one question of the class number, just one. Try this. I have an idea. That is the answer. Well, it didn't give any rate. It didn't move it n equal to 1. Oh. Alright, yeah, it is specified. Sorry about that. But no, just put start from 2. Want to figure it out already? So why do I have 1 there? Why do I have 1? Ooh. Oh, yes. Anybody done? To look up? right? So when n is 2, you see it? Sure. Right, when n is 2, so it's 1 over 2 by 2 minus 1, which is a half. Right hand side is 1 minus a half, which is a half. So it holds when n is 2, right? Here now, assume true for n equal to k. So it's 1 over r by r minus 1 is equal to 1 minus 1 on k. Right? So here it would be 1 over r by r minus 1. You're plugging k plus 1 here, and you're plugging k plus 1 here. So it's 1 minus 1 over k plus 1. You may not get your answer like that, so you can probably find the LCM, right? So the LCM here is k plus 1, and then you'll get k plus 1 on top minus 1. So that'll cancel, and you'll get k, right? So you might be trying, you should try to get this instead. Oh, you get this? No? But I give you some time. 2 minutes again. I hope this thing right. Say she go out. Yeah, who's your point? What on it? Yes. Oh, that's why you say that's not. That's why you say that's not. Anybody guys online? All right, so the main mistake of seeing is this, right? The main mistake of seeing this is this here, right? You got that part right? That's 1 minus 1 on k. But the k plus 1 term is not this. This here is the sum of all of this, right? If you want to get the k plus 1 term, put k plus 1 here and here. So it will be 1 over k plus 1 by k plus 1 minus 1. Just k. Here, you can find the LCM if you want. This is k. So here you will get k minus 1. And here you will end up with 1 over k by k plus 1. Cover? How about what? Huh? K plus 1 by k. I just switch them around. Right? So what do we want now? We want to get k over k plus 1. Right? You want to get k over k plus 1. So you want to get one fraction. Right? So one of the options that we could take here is to find the LCM. Right? What's the LCM of these two? K by k plus 1. Hopefully this will cancel up on top later on, right? K by k cancel. You'll get k minus 1 by k plus 1. Right? This k will cancel here and you'll get this by this. Then this will cancel with this and you'll get plus 1. Right? This is difference of two squares. So that's k squared minus 1 plus 1 all over k by k plus 1. Right? What will happen here? This will cancel. And then this k will cancel with this square. And you'll be left with k over k plus 1. Right? So the main mistake I saw was this. Some of you are substituting the wrong thing, right? This k plus 1 term is putting k plus 1 in whatever you have here, next to the summation sign. This is the general term. So you substitute this to get a general term. This is what you're trying to get when you finish the last step of the PMI. Right? One more hard one, then we move out to this. Next week is we're gonna have break next week. I think about that. Which Friday? For what? Oh, that's what no. Sorry, and I did. Oh yeah. Sorry. Alright, any questions online? Alright, well, I thought I gave you an easy one there, but I'll give you a hard one. Huh? I only give you one. Right, just one hard one. Huh? Just to make sure you see if one working. Now that's it didn't say it. I check it to see if it working for n is one. 1/2. Yeah. It working for n is one. Last one. And then we're going to go back into series. We'll do the form 5 part of series, right? Try this one here. Right. So basically, people get to Anybody get it? I just plug in the first few parts to make sure you have that, right? Yeah, so we're trying to prove that. Trying to prove that. Anybody get it? Okay. Okay. I'm giving you something. All right, Ruel, so you'll help more with it. Watch out, watch out. Watch out, guys. That's right. Now the usual pass. Anybody get it online? Right, so you should at least have up until here, right? Right. What we're going to do. What we're going to do here? Any ideas how we get started? We have it 2 already. Right? We can probably what, factor out a half from here. So before we factor out a half, right? 2 to the k plus 1 is the same as what? 2 to the k by 2 to the 1. So we can factor out a half. But then if you factor out a half power. So could we factor out? I just want to write this one more. I just want to write this a little bit different for you. I might see the answer, right? So I'm going to factor this. I'm going to write this a little bit different. This is 1 over 2 to the k. Correct? That's okay? Oh, what I did? I had 1 on 2 to the k, which is 1 to the k by 2 to the k. This is 1, and this is 2 to the k. So I wrote this like this, right? Now, you might see that you can factor out, but you can factor out 1 on 2 to the k from both sides, right? So we have the 2, don't touch the 2 because the 2 on the outside is. We're going to factor out 1 on 2 to the k, right? And here we'll be left with k plus 2. And here, I'm factoring out this 1 on 2 to the k, right? So I'll get k plus 1 over 2. That's okay? Yeah? So far, everything looking okay-ish, except I need to get k plus 1 here instead. All right? So what might happen? Please don't subtract this. I'm not doing this still. Don't subtract this, right? This is the whole term here. Right? Don't subtract this because it's looking nice and you will get 3 on 2, right? So what we can do in here, well, we have 2 fractions here. So what we should probably do. You have two fractions in the answer. So we had to get rid of the two fractions, right? So how we can do that? LCM, right? 1 by 2 is 2. Right? 2 by k, 2 by 2. 1 by k, 1 by 1. Again, 3k plus 5. Something over there. That a minus. Oh. What do you? I factored out minus. So this is supposed to be, right? Minus by this is this, minus by a minus is this. All right? So this is minus k minus 1. Sorry about that. Right? So when I multiply back this, I was supposed to say, check and see if when you multiply this, you get back this. Right? So my sign here was wrong. That's why I didn't get it plus 3. So I get in 2 minus 1 on 2 to the k. 2k minus k is k. 4 minus 1 is 3. All over 2. Right? I could factor out this 2 and bring it here. So I'll end up with 2 minus 1 on 2 to the k plus 1 by k plus 3, which is the same as that. 2 minus 1 on 2 to the k plus 1 by k plus 3. Online, any questions? Was it? Okay. Yes. 1 by LCM, same format. 1 by 2, 2 by this, 1 by this, and put it sign in it. That's it. 1 by 2 is 2, 2 by k is 2k, 2 by 2 is 4, 1 by minus k, 1 by minus. Yeah, probably you could. But okay with that? So that's the PMI, right? Now we're going to focus really on series. What are the two popular series that you all know? AP and GP, right? So we know how to sum the first n terms of our AP. We know how to sum the first n terms of our GP. Anybody remember which is convergent? Okay, which is that is an AP divergent or convergent? Is an AP divergent or convergent? AP divergent. AP doesn't converge to anybody, right? But a GPS, a GPS convergent. All right, so a GPS convergent, right? Anybody remember when a GP convergent? When is a GP convergent? Remember when I was between something? Anybody online? Anybody online remember when a GP is convergent? Kilan, anybody online? When is a GP convergent? GP. When is a GP convergent? You have particular condition. Right? Correct, Jada. Between -1 and 1. Right? Between -1 and 1. All right, so we just go and run through that. Most of those things you know already, but we just have to go it over, right? Oh, sorry. I put that over. Sorry, what? Ready? Right, let's take a small note. A series, add up series. Take a small note, right? Is add up series. A series is a sum. A series is a sum of all the terms in a sequence. A series is a sum of all the terms in a sequence. For example, this here is a series, right? If I gave you the sequence a to the r, and then we're going to we're going to sum all the values of r from 1 to n. This series is written plug in 1, a1, plug in 2, plug in 3, all the way until second to last term, right? So we can know this already, but it's just formally to define a series. It's just take a sequence and add up all the terms in it. All right? Right? And two popular types. Two popular types of series are one, an arithmetic series. We are try every. I'm missing somewhere. Yeah. Right? An arithmetic series and a geometric series. Let's check it and make sure. Yeah. You let it know? Huh? I know there are eyes somewhere here.
Yeah, the eyes.
Oh, it's something like that. All right. So you have an arithmetic series and a geometric series, right? What are the parameters for the arithmetic series again? An, first term, and common difference. Right? And we need to remember how to sum all the terms. S to the n is equal to n on 2 by 2a plus n minus 1d. Or you have the last term formula as well, right? Actually, I'm going to give you the general term in case you forget that. Huh? Although I think I gave you this earlier. Eh? No? And then here will be S to the n is equal to So just some of the things that we need to remember for AP and GP, right? Right, these are the general terms.
Small price of the exam. Yeah, I've got it.
How long is it? So long? Just a fair, huh?
I think it's 40. Oh, you were. Because it lasts. Oh, that's not fair.
All right, ready? So how do we, what would it look like in unit 2 now? In unit 2, they're going to give us something and we have to figure out what it is, right? Ready? All right, so, can open or close? Close now. All right, so let's take a look at a little example, right? Right. Let's say I give you, let's say you have a formula like that for the sum of the first n terms. Right. Here's what we need. We got to find a few things. The first thing that we want to find is we want to determine if it's an AP. This is all I give you. I give you S to the N. Right? You want to determine if it's an AP or GP. Second thing we have to determine is the nth term. Right? This will be easy, right? What we have to do is figure out if it's an AP or GP. How are we doing that? How are we going to use this here to help us determine if it's an AP or GP? This is sum of the n terms, right? How are we going to use this here to determine if it's an AP or GP? right? What does this mean? This means it's summoning all the n terms, right? So suppose it had S2. What does that mean? What does S2 mean? Sum of the first term and the, what does S3 mean? First three terms, right? What is S1? So S1 is the first term, right? So S1 is equal to the first term, which is 1 by 3 minus 2, which is 1. S1 is 1. That's okay? So we know what A is. How we can get the second term? Which one? S2 by S2 minus S1, and S2 minus S1 will give you the second term. Right? So what is S2? S2 will be 2 by minus 1. 2 by minus 1 minus 1. Minus 3. Yeah? How we get the third term? Because we need the terms to kind of figure it out. Yeah? How we get the third term? S3 minus S. Right? So you see how we can use this formula to help us get the terms, right? What is S3? S3 is 3 by 3 minus 6. Right? And then you're minus in S2. S2 was minus 2. So I got 9. I got 9 minus 9 plus 4. No, S2. S2 was here. S2 was here, right? So that's minus 9 plus 2, 7. Minus 7, right? Everybody okay with that? So by looking at it, AP or GP? AP. Same that? Drop by 4. Drop by 4. So remember how to check it, right? See, subtract 2 consecutive terms. Subtract 2 consecutive terms. And if the value is the same, right, then it's a AP. Any questions online? Oh, and then part 2 is what? Huh? Part 2 is what? So yeah, that's one more year. People kind of shine away from it and just do it now. How we tell, yeah. Yeah, yeah. No, that's right. irregular. But something with catch you. Hey, you just have to keep it running or put it in. Okay, that one was like easy one marathon. So we have a thing and ready? One again. You know that? Same principle, though, right? Same principle, right? So S1 is equal to 2 to the 4 minus 8. Yeah, but I'm not playing now. I'm playing on you. I might have to give us something. I would still have to run now. But I can't make for the rest of the year. What's this all here? How much is this? 8. Let's just work out all one time now. S2 is what? Huh? You want to walk? And so that is something. How much is this? 24. And I just doing S3 one time, right? S3 is no, not T2 anymore. S. So 16 minus 8, right? What is this? What's 32 minus 8? Right, so that's 24. That was correct. And this 64 minus 8, right? So that's 56. Right. Yeah? No, I did it different to that. Right? Now I'm going to find everything. So T1, which is 8, T1 is 8, T2 is S2 minus S1, which is 24 minus 8, which is 16. That's okay? I just do it a little bit different to the last one, right? T3 is S3 minus S2, right? S3 was 56 minus 24, right? That's what? 32? That's 32. How it looking? AP or GP? It's looking like a GP. So R is equal to 16 divided by 8, 32 divided by 16. And they both given you 2. So therefore, A is equal to 8, R is equal to 2, therefore it's a GP. They want the nth term, so T to the n is equal to A by R to the n minus 1. Is S1. Cover? Huh? How about? You got it? Now for term 2. What? You got it, Sundays? 2 to the 5 is 32, right? 32 minus 8 is 24. Right? And then 24 minus 8 is 16. Am I just got it? Yeah? Right? So it's a AP. Well, it had to be 16, otherwise I'm wrong, right? It had to be 16, right? 8 by 2 by 2, right? What's that? That's AP? It's a GP. Right? It's a GP. All right, nice. Any questions online? Already worked up. All right, so nice. Online. All good? Someone will say nothing at all. Are you okay? Right, William? You're writing notes Sunday? Guru, not good? Right, so have a break next week. Next week, Wednesday, have a break, right? And after that, we'll finish up series. We have binomial, McLaurin's, and then roots. McLaurin, Taylor, and then roots, right? Friday online. I will send a reminder to tomorrow. All right, online.